Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post, Vector Search from the whiteboard to the cloud. Vector search is one of those ideas you can sketch in 5 minutes and then spend a quarter getting right in production. So we do both halves, the whiteboard intuition first, then the managed pass on AWS. The clearest short explanation I've seen is Mike Pound's computer file video on vector search. You run text through an embedding model and it outputs a fixed list of numbers that places the text as a single point in a high-dimensional space. Similar meanings land near each other, the same trick as Face ID, but for sentences. And to measure similarity, you compare the angle between vectors, not the raw distance. Length is noise, only direction carries meaning. Here is the whole recipe on one diagram. Embed the query, search the index by angle, takes the top k nearest neighbors, optionally re-rank, and hand the text to the model as context. You embed your corpus once and every query is a fast lookup. And the matching is forgiving, misspell a word or phrase it awkwardly, and the embedding still lands in the right neighborhood. The recipe is correct, and it is also where most of the real work hides, because every step has a knob chunking. Too large and one vector means nothing in particular, too small and you shred the context. Recall versus latency, approximate indexes, trade accuracy for speed. Embedding drift, change the model and every stored vector is now in a different space. And metadata filtering, so you don't return a confident match from the wrong tenant. You might ask, saying chunking has no universal right answer sounds like a cop-out. It's genuinely workload dependent, but there is guidance. A few hundred tokens with overlap is a reasonable start, and structure-aware chunking by heading or paragraph usually beats fixed size. The honest answer is you measure retrieval quality on your own queries and adjust. It's the first thing I tune when retrieval is poor. On AWS, Amazon Bedrock Knowledge Bases runs that whole loop for you. Per AWS guidance, you point it at your data, and it fetches the documents, chunks them, converts the text to embeddings, stores them in your choice of vector database, and keeps them in sync as the source changes. The 4 whiteboard steps become managed on the read side. The retrieve API embeds your query, searches, and returns the matching chunks with scores. Let me switch to the source for that. This is the AWS prescriptive guidance on knowledge bases for Amazon Bedrock. It documents the managed ingest, chunk, embed, and store loop. The supported vector stores like OpenSearch Serverless and Aurora PostgreSQL and the 2 read APIs retrieve and generate. That knob of a results parameter is just the recall versus noise knob. Now a single setting. I want to be clear about the trade, because managed is not automatically the answer. My own setup is the counterexample. The assistant I use for this work is built on Kiro CLI plus an Obsidian Vault, and its retrieval over my nodes is plain text search, not a vector store at all. For a few hundred markdown files whose vocabulary I know, keyword search is faster to reason about and never returns a confidently wrong neighbor. So you might push back. Why use vectors at all? When keyword search adds cost and complexity? For small, stable, known corpora, keyword search often is the right call. Vector search earns its keep on large, paraphrase-heavy, or multilingual corpora where semantic match and typo tolerance matter. And hybrid search, keyword plus vectors, often beats either alone. Vectors are not automatically superior. Here's a rough decision tree. The axis is corpus size, query volume, and how much of the loop you want to operate, not cloud versus not. Small and known corpus leads to do-it-yourself keyword or local search. Large or growing with unpredictable queries leads to either Bedrock knowledge bases if you don't want to operate the loop, or a self-managed vector store if you do. And isn't managed just a polite word for login? No, Bedrock knowledge bases lets you bring your own vector store. Aurora, pgvector, OpenSearch, Pinecone, and the embeddings. Live in your account behind standard APIs. The decision criterion is corpus size, query volume, and operational load, not a value judgment about the cloud. Both DIY and managed are legitimate. For a managed retrieval layer, the concrete mapping is Amazon Bedrock Knowledge Bases for the ingest chunk embed store loop and the retrieve APIs. For the vector store, start with Amazon OpenSearch Serverless, which Bedrock can provision for you, or bring Aurora PostgreSQL with pgvector if you already run Aurora. And Amazon S3 is the simplest data source, with incremental sync so only changed content is recrawled. This builds on an earlier post of mine on whether RAG is still needed, even with million token context windows. That one was about when to retrieve. This post is one level down on what the retrieval is actually doing. Retrieval and long context are complementary, not competitors. This was the retrieval half. Part 2 goes deeper into chunking and embedding choices, where the production knobs actually get set. Part 3 connects retrieval to the rest of a working system, including how a model decides which tool or store to call. If you keep one thing, vector searches embed, then find the nearest neighbors by angle. Everything in production is in service of making those neighbors the right ones. Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly or head to my blog at schristoph.online. Let's keep in touch. Take care.